All right, it's time to get started here. This is the Northwestern Michigan College student presentation. We've got two students with us today, Aiden McHugh and Dan Fulmer, and they're going to talk about their project. But first thing, just a reminder that your phones are silenced so we don't have any interruptions. And then after this is lunch, I'll make an announcement at the end of the session here. But code for you guys, 82A7. 82A7. Aiden, Dan, take it away.
Thank you. Hi, everyone. My name's Dan Fulmer. This is Aiden McHugh. We're going to talk a little bit today about some of the work we've done in the past 3 years on our hydroelectric dam inspections.
So in the fall of 2024, we were students in a class called WSI 240. This class focuses on ROV maintenance and upkeep and a lot of ROV scheduling. And so a lot of this time is spent out on our research vessel, the RV Northwestern. And so students learn how to handle ROVs and then also make end products. We were contacted by our client to do an inspection of a hydroelectric facility. And so that was a really good experience for the students in that class, Dan, myself, and others. Since then, we've done 3 in total, and we're now looking at doing a 4th. 2 have been during classes, and then 1 has been done as an extracurricular activity through the Marine Tech Society, Northwestern Michigan College chapter.
So when we first met with our client, we really wanted to nail down the scope of what the project we were doing. So what that looked like is they came to us, they said, hey, this is what we need, this is what we would like to see from you. And then we would come back and say, this is the equipment that we have, this is what the capabilities are, how can we supply you with the deliverable that you want. And at first, our client wasn't too familiar with some of the sonar and some of our capabilities. So what that looked like was us teaching them what an end product and deliverable looked like on our end. And then we went into our preparation phase. The first thing we did was create a packing list of all of the equipment that we needed. And the first time we did it, we didn't really know what we needed. So our solution to that was, well, let's just bring everything and then see what we have time for. And then obviously when we got on site, we learned what we needed for the next time, and then we could better prepare ourselves in the future. So we brought ROVs, scanning sonar, all of our PPE, and our support gear to the first job site.
So the main equipment we used was our Kongsberg 1171 scanning sonar, our blue ROV2, and our Outland 1000. These 3 pieces of equipment have been the workhorse of these inspections, and each one serves us a different purpose. The Kongsberg 1171 scanning sonar does a 360 sweep using sonar to image the bottom. This was great for making mosaics and showing our client what exactly is on their bottom and potential targets that they could need to identify. The blue ROV2 has a sonar on it. It's not as nice of a sonar, but it has a great camera on it. For our most recent inspection, it was mainly a visual inspection looking for breaks, cracks, that kind of thing. And so we use the blue ROV2 mainly for that. And our end deliverable in that part was a nice document showing pictures and videos of what they were looking for. The Outland 1000 is a pretty nice mixture between the two. The blue view sonar, which is that black circle on top of it, it's a great imaging sonar, again, top down, but it's real time instead of taking time to do a full 360 scope. And so in areas of low visibility, which in these hydroelectric facilities, there was a lot of low visibility, Dan was able to fly just using that sonar. It also has a camera, but not as nice of a one. So like I mentioned on our most recent one, we started with the Outland 1000. It's shore power instead of battery power, while the blue ROV2 is battery power, and that's a huge limitation for us, especially on these longer days. So we started with the Outland 1000. The camera wasn't what we were looking for in this job, so we got our blue ROV2 going and ready to inspect these cracks that we were looking at. Getting on site was its own logistical issue. Google Maps helps, but you don't know a lot of what the roads look like until you get there. A lot of times you're driving down these long back roads and you're driving a rig that's 30, 40 feet. You've got a truck and your trailer full of equipment. And so at first we were just like, we would drive right up and put our equipment in. But when we got out there all 3 times, it ended up being a very different situation. For example, site 3, we turned down this long dirt road that we thought would take us to the facility, and we ended up hitting a dead end. And there was no way to turn around. There was embankments on both sides, but there was one little alcove. So we drove as far forward as we could, disconnected the trailer. We were able to get 3 or 4 guys to lift it and push it out of the way, and then get the truck turned around and then put the trailer back on and go to the correct site. So getting on site really was something you don't think of while doing these plannings. And so once we kind of got more experience, it was something we were able to plan for more. Gear setup too. These hydroelectric facilities are 2 to 3 hours away. And so you have students who have responsibilities back at the college. So once you get out there, it's really, you need to be quick setting up so you can get the data for your client, so you don't have to spend money going on gas, getting out there, and getting out there. So you have a limited time to set up and tear down. And so you have a lot of equipment that needs to be put up so that you can get your equipment in the water as fast as possible and start collecting data. What we found works is assigning everyone jobs before they get on. So during your initial planning meetings with your team, what you have to do is take each person, realize what your needs are for getting out there. And that way, when you get out there, nobody's standing around kind of, what do I do? Everyone puts on their safety equipment and gets right to work, and you can start collecting data as soon as possible.
Yeah, with the gear setup too, we kind of have to improvise a lot. So on the second site that we went to, we thought that we were going to just be able to deploy our scanning sonar quick and easy, do it just as planned. But we saw that the wall that we were going to deploy it off of was about 40 feet longer than we thought it was going to be. So we had to actually use a 2x4 that we found somewhere on the job site to push the scanning sonar off the wall to actually get it down into the water. So that was something that we just kind of improvised on the fly. We're always fighting with the sun too. If you can see in this picture, we had our tarp down so we could actually see our screens and fly the ROVs. Looks a little goofy, but I mean, it worked fine. Another challenge that we've had on our sites is the spillway of the dam was still up and running, so it was really high currents. It was very difficult to fly the ROV. It was pretty much unable to work at all. So what we ended up doing is we split into 2 teams. One team held the tether, and then I was piloting, and I basically just had to keep it straight and try to hit as little things as possible. So we just had a team hold the tether, let it go slowly out and go down with the current, and then pull it back up and do the same thing all the way down the spillway.
And on that note, communication is a very important part of this as well. The team holding the tether was about 100 feet up an embankment, and while Dan was sitting in our trailer piloting the ROV. So we had walkie-talkies, and the entire time we were communicating back and forth with these employees of our client who was still new to this equipment. So part of it was getting on site, teaching them kind of what to do and how they can help us, and then communicating with them the entire time. So this is an example of what one of our end products look like for our client. And so this was collected using that 1171 scanning sonar that we were talking about. Dan did a very nice mosaic of this. It's called a tub. And so we put the scanning sonar down in this tub, and then the tub was connected to these spill bays. And so while he flew down into those spill bays, myself and another student collected scans for a mosaic later. That way, our client could see what was going on at the bottom and look for any potential riffraff or issues or blockages.
Yeah, this is just another example of what a deliverable looked like that we provided for them. This was captured using our Blue View sonar that we saw mounted on top of the Outland 1000 ROV. Here you can see the intake side, and it also shows some debris in there as well, which happened to be what the client was looking for on this particular site.
So this is an image that we thought was pretty cool. It's pretty similar to the last one that I was telling you about. So right about halfway, you can see we couldn't collect anything. And so while we were on the job site, we were like, we're not sure what's going on here. We can't see half of the tub. We should have the range to go all the way out and see the entire thing. And so we spent a while looking at the computer, and we decided the best thing we could do in that situation was to look up from the computer. And we noticed that since they couldn't they couldn't turn the entire facility off at once, they had to keep part of it on. And so we looked over and we saw that the part of the facility that was on was just pushing a massive amount of bubbles out. And bubbles and sonar do not go very well together. Bubbles are very acoustically dense, and so the moment that the sound hits the air inside of the bubble, it'll bounce back to the receiver. And so we realized that these bubbles were creating almost like a wall of sorts, a very acoustically dense wall, and we couldn't get all the data we needed because of this. And then we tried to work our way around it, but we realized that the current was too much and it would take too long to switch the flow. And so we weren't able to lower our scanning sonar down into that second part. In conclusion, this opportunity was great for us as students. In industry, we have students who go on to do inspections just like this. Tyler Bristol, who is a part of Hibbert Inshore, he travels all around the world doing very long tunnel and dam inspections. David Bears, who's a part of ASI Group, does the exact same job. This gives us real world experience and real world skills that we can carry into our future, and once we graduate, go on to potentially do jobs just like this.
Yeah, and I mean, I know for myself and all of the other students that have been involved in these projects, it's something that we're all super proud of. You know, being able to actually talk with the client yourself, collect the data yourself, process it, and then deliver something to the client that they're happy with. That's something that's very valuable to us and that we're very proud of. And so going into the workforce as well, I know this is on my resume, so I mean that's something that companies love to see, and it definitely gives us a lot of future opportunities. And then we hope, because we graduate in May, that this relationship that we have with this company can continue forward as well. Yeah. All right, thank you. Any questions?
Yep.
Is your client looking for the debris so that they can get a volume and how much they got to remove out of there, shutting out for remove? Do you know what they're shooting for here?
On our end of things, they didn't share that with us. Our end of things was purely to collect them the data for future use.
You mentioned they like the camera on the blue ROV2 more than some of the other units. What reason is that?
The blue ROV2 gets better color, it gets better quality of image than our Outland 1000. And it's really a lot based on age of the camera. The Outland 1000 is about 15, 16 years old at this point, while the blue ROV2 is manufactured about 2018, 19. And specifically, it was built for these visual inspections, so it's got 1080p, we can put a GoPro on it to get 4K, and then a lot, like the frame rate and that kind of stuff is better. Yep.
So when you were traveling to these sites, you had to go several hours to get there. Did you have a way to determine whether there's going to be turbidity in the water or anything that would be problematic before you got there?
Yeah, not exactly. So we kind of played it by ear. We knew a little bit of what the site was going to look like because we saw some aerial photos and things like that. They would tell us that they could be able to shut down half the dam at the time, so we could not have to fight with the currents as much. But really, we didn't know until we got on site most of the time.
And on that note, Dan is a very good ROV pilot, and so we were able to trust him with being able to handle these currents.
Just kind of follow up on that. It sounds like you ran into a lot of different things as you were going along. So did you document those and are you putting those into lessons learned and so that other people can, in the future, can reference back to that?
Yeah, so for every inspection that we did, we ended up writing a technical report as part of the data processing deliverables that we did. And then from then, we made a set of SOPs that go along with doing these inspections as well.
Yeah, in each of those reports, there's notes about how fast the current was moving. And then as we graduate, we'll pass that along to students for them to reference before they get out there. Our most recent inspection as well, we brought a lot of younger students. So Dan and I we took hands off of the actual data collection and took more of a project manager, team leader role. He did ROV, I did the scanning sonar. And so as we graduate, we were able to give these students kind of experience out there so that as more inspections, as we hope, comes up, they're able to now take the experience from the one we did with them and apply that for the next few years.
I'm sure they'll have their own learning curves too, just as we did. Yeah.
I'm not familiar with the Kongsberg 1171 sonar that you used because as I looked at the pictures, it was kind of sitting on a tripod
Mhm.
stand or whatever. How do you physically use that to get your measurements in advance?
Will you go back to the slide? So each,
I'm not familiar with it.
yeah, so we can give you kind of a show. So each of these red rings are a known distance away from the center. The center, you can kind of see there's 3 little dots, and that's where the sound is hitting the tripod. We use MS-1000, which is a Kongsberg proprietary software. It has measurement in it. And then we also use the Blue ROV2 to get depth measurements. So it was between a combination of the known points and then also the Blue ROV2's depth measurements. We were able to put in our report, say they were looking for some riffraff. It's 15 feet away from where we dropped it at a depth of 18 feet.
Yeah, the software does have measuring tools inside of it as well that we're able to take, from point to point, and it'll tell us the distance or anything like that. Anybody else? All right, well, thank you, everyone.